All right, next in our unit on rational functions, we're going to learn how to solve rational equations. And as we learn to solve rational equations, we're actually going to use a very similar approach that we use to simplifying complex fractions. So first we've got 1/7 plus x sevenths equals 5/7. And this problem is pretty intuitive here. You can see if they're all sevenths, what I'm really dealing with is just solving 1 plus x equals 5. And if I have 1 plus x equals 5, then I can just subtract the 1 over and I can get x equals 4. So what we're going to do when we work with a problem like this is we're still going to go through just like we did with complex fractions, and we're going to look, for the least common denominator. So for this, it would just be 7. And then what we're going to do is we're going to take the entire equation and we're going to multiply the entire equation by that least common denominator. So we're going to take that and then we're going to distribute that to each of the terms. So when you do that, 1/7 multiplied by 7 is 1. X sevenths multiplied by 7 is x. 5/7 multiplied by 7 is 5. So for this problem, it's pretty intuitive. We could just think of that because all of the denominators were the same. In other problems, it will be a little bit less intuitive, but the method still works. So let's go ahead and try a problem that is less easy. So for this problem, we're going to have 1 plus 1 over r minus 1 equals 4 over r minus 1. Now, when we solve equations, there's one more thing we have to consider, and that is when we get a solution, is it an excluded value? And in most cases, it's not, because if we think about all the numbers in the world from negative infinity to positive infinity, the excluded values are very limited compared to all the possible answers we could have. So of all the answers in the world, of all the numbers in the world, the excluded value we have here is 1. So every single answer is permissible as long as our answer is not 1. So the very first thing when you're solving a rational equation is you want to write down your excluded number because you want to make sure that your answer is not this number. As long as your answer is not this number, you are good. All right, so my least common denominator here is going to be r minus 1. So what I'm going to do is I'm going to take the entire equation and I'm going to multiply the entire equation by r minus 1. So I'm going to distribute it to each thing. So I have 1 multiplied by r minus 1 plus 1 over r minus 1 times r minus 1 equals 4 over r minus 1 times r minus 1. And when I do that, I get r minus 1 plus 1 equals 4. So when I do this, now I have an easier equation to solve. I've got -1, +1, those cancel out. I get r equals 4. I'm going to double check and make sure that my solution is not that excluded value, and as long as it's not, I'm good to go. R equals 4, that's not 1, and so my answer works. All right, example 2. I have 4n plus 24 over n plus n minus 4 over 2n equals 1 over 2. So the very first thing is I'm going to look at my denominators and figure out what my excluded value is. So I can see n cannot equal 0, n cannot equal 0. All right, and I'm going to check the excluded values just in the first couple steps, make sure my excluded values are pretty consistent. I'm going to look for my least common denominator. I can see that it's 2n. So I'm going to take the entire equation and multiply by 2n. So I have 4n plus 24 over n times 2n plus n minus 4 over 2n times 2n equals 1 over 2 times 2n. So for my first term, the n's are going to cancel, and I have the 2, which can distribute. So I've got 2 times 4n, which is 8n, plus 2 times 24, which is 48. The 2n and 2n cancel, I just get n minus 4. The 2 and the 2 cancel, and I just get n. And so now I can go ahead and just combine my like terms. I have 9n plus 44 equals n. I'll go ahead and get my n's over to one side. So 44 equals negative 8n. I can divide by negative 8. Oops. Negative 44 over 8. The top and bottom are both divisible by 4, so I'll go ahead and do that. So n equals negative 11 over 2. And negative 11 over 2 is not that excluded value, and so that answer is a good answer. So as long as I'm always checking to make sure my final answer is not my excluded value, I'm good to go. And to be honest, most of the time it's not. It's possible, but most of the time you're good to go. All right, so next problem, m minus 1 over 3m squared minus m minus 1 over 6m squared minus 2m equals m squared minus m minus 12 over 12m squared minus 4m. So this is a problem where for us to find our least common denominator and for us to find our excluded values as well, we're going to have to see those denominators in their factored form. So here I'm going to see that my denominator, to factor that, I need to take out a GCF of m. So I have the m, and then I have 3m minus 1. Here I have a GCF of 2m, and then 3m minus 1. Here I have a GCF of 4m, and then 3m minus 1. So when I consider this, I can see that my least common denominator, did not leave a lot of space there, definitely needs to have a 3m minus 1, for sure. And then if I look at my GCFs in the front that I pulled out, I definitely need to have an m in the front, because they all have m. And then in front of the m, I can see a 4 and a 2, and then just a 1 here. So between 4 and 2, I need a 4. All right, so now considering my excluded values, I can see based on the front part, x cannot, or not x, m cannot equal, for the front part, m cannot equal 0 for this part. And then for this part, m cannot equal positive 1/3. M cannot equal 1/3. Okay, so I'm going to go ahead and rewrite this and give myself a little bit more space before I figure out what I'm multiplying. So m minus 1 over m times 3m minus 1, 2m times 3m minus 1. So it's going to be a little bit easier for me to do this part where I multiply by the least common denominator. It's going to be a little bit easier for me to do that if I'm dealing with the denominator in its factored form. So I'm going to multiply the entire equation by the least common denominator. And I'm going to distribute that. And so for the first term, I've got m minus 1 over m times 3m minus 1, and that's being multiplied by 4m times 3m minus 1, minus 1 over 2m times 3m minus 1 times 4m times 3m minus 1. Uh-oh, I'm running out of space. Equals m squared minus m minus 12 over 4m times 3m minus 1 over 4m times 3m minus 1. Okay. So for the first term, I can see the 3m minus 1's definitely cancel, and then the m cancels, and I'm left with 4m minus 4. Right? For the next term, I've got 3m minus 1 cancels, m cancels, and then the 4 and the 2 just reduce. So 2 goes into 2 once, okay, so that's basically gone, and then 2 goes into 4 twice. Minus 1 times 2. All right, and then over here we have 4m times 3m minus 1, 4m times 3m minus 1, so that entire thing cancels with that entire thing. These are all completely gone. So equals m squared minus m minus 12. So there we have just an entire quadratic. So we have 4m minus 6 equals m squared minus m minus 12. So what it looks like here is we have a quadratic equation that we're solving. And the way to solve a quadratic equation is to make it equal 0. So I'm going to subtract the 4m over and add the 6 over. So 0 equals m squared minus 5m minus 6. So we're looking for two numbers that multiply to negative 6 but add to negative 5. Those two numbers are negative 6 and 1. And so m equals 6, m equals negative 1. If I go back and compare that with my excluded values, I can see that my excluded values were 0 and 1/3, which means that these are both good answers.